हेलो एवरीवन। आज हम फिजिक्स फर्स्ट ईयर के चैप्टर नंबर 1 मेजरमेंट्स के कंसेप्चुअल क्वेश्चंस करेंगे और ये क्वेश्चंस हमने केपी के टेक्स्ट बुक से लिए हैं जी। सो क्वेश्चन नंबर 1 is for an answer to be complete the unit need to be specified. Why? Its answer is for an answer to be complete, the unit need to be specified because the measurement of any physical quantity is made relative to a particular unit or standard. What does it mean is that, for example, a reading 16.2 just gives the value of magnitude. It can be 16.2 meter, which means it could be the length, or 16 kilogram, which means it could be the mass, and etc. So the units are necessary for recognition of physical quantity. Question number 2 is, what are the advantages of using international system of units? Advantages of system international units are: SI system is coherent system of units, a system based on certain set of fundamental units. SI system is rational system of units, that is, it assigns only one unit to a particular physical quantity. And the next one is, SI is internationally accepted system of units all over the world, that is, these units are useful for international trade purpose. Question number 3 is, how many radians account for the circumference of a circle and how many steradians account for the circumference of a sphere? A radian is basically an angle made by an arc of a circle whose arc length is equal to the radius of the circle. If we consider the circumference of a circle, then by relation we are familiar with, S is equals to r theta. Angle in radian is equals to the circumference of a circle over radius. Since circumference is equals to mathematically equal to the 2 pi r over r, r and r will be cancelled out with each other and we will be left with angle in radian is equals to 2 pi radians. Now the steradian is defined as the solid angle subtended at the center of a sphere by an area of its surface equal to the square of the radius of that sphere which we are considering. Mathematically, we may write it as the steradian is equal to area of a sphere divided by the square of radius. Since area of a sphere is mathematically equal to 4 pi r square and divided by the square of the radius, r square and r square will be cancelled out with each other and we will be left with the angle in steradian is equals to 4 pi steradian. So a sphere subtends the 4 pi steradian about the origin. Question number 4. What is the least count error and how can the least count error be reduced? The smallest value that can be measured by the measuring instrument is called its least count, and the least count error is associated with the resolution of the instrument. Means that how minutely we can differentiate between the two smallest and the consecutive rulings on that particular measuring instrument, that is related to the resolution of the instrument. And the error means that the doubt generated by the measurement taken from those smallest possible consecutive distant rulings is basically the least count error. And the remedy for the least count error is instrument of higher precision can reduce the least count error. Means the instrument with highest possible absolute uncertainty, which further means the instrument which will be having the lowest possible least count will be generating the least possible error, least count error. By repeating the observation and taking the arithmetic means of the result. And the final, the mean value would be very close to the true value of the measured quantity. Question number 5. Why including more digits in answers does not make it more accurate? The answer is, as accuracy means the degree to which the result of the measurement conforms to correct value or standard. So adding more digits in answer does not make it more accurate. The more digits improve the precision but not accuracy. Question number 6 is, what determines the precision of a measurement? The precision of a measurement is basically how it tells us how close a measurement come to another measurement. If using a particular tool or method achieves similar result every time it is used, it has high precision, such as stepping on a scale several times in a row and getting the same weight every time. Question number 7. If two quantities have different dimensions, is it possible to multiply or divide them? Can we add or subtract them? Its answer is, as per the principle of homogeneity of dimension, addition, subtraction between two quantities of different dimensions are not possible. For example, we cannot add the length into area, while dimension and multiplication are possible. For example, in relation for velocity, we have v is equals to displacement over time. Since the displacement is a physical quantity we use for measurement of length, and the time is the physical quantity we use for the measurement of time. These are two different quantities and we can divide them. So we can divide and multiply two different quantities, but we cannot add them. Question number 8 is, the human pulse and the swing of pendulum are possible unit of time. Why are they not often used? As human pulse is not a good standard because it varies from age to age, and also human pulse varies with physical exercise. And the swing of pendulum cannot be used as the time unit because the unit for one complete swing, that is time period, depend on the length and gravitational acceleration, as by formula t is equals to 2 pi L over g. We also know that the value of g varies with the square of the distance from the center of the earth. As we move from the surface of earth to the higher altitude or towards the center of the earth, the value of g will vary. So that's why we cannot use the swing of pendulum and the human pulse as the standard time units. Question number 9. If the equation is dimensionally correct, is that equation a right equation? Answer. The dimensions are used to determine the nature of the physical quantity mathematically. According to the principle of homogeneity, the dimensions of both sides of an equation should be same. If this exists, the equation is said to be dimensionally correct, but it is not necessary that it is a physically correct equation. For example, the equation S is equals to Vt plus half is dimensionally correct, but we know that it is not a physically right equation.